Hey guys, Mr. Riz here. So I'm going to walk you guys through the optional review. So this is for Chapter 1 in Algebra 2. This is something you guys don't have to do for points, but it's just extra practice to get you ready for the test. So if you wanted to, you could download this optional worksheet for help, actually, or it would be printed off for you. So the first day you guys come in this week, it'll be in the back. I'm going to go ahead and open it up, and hopefully you guys can see this here. I'll double check this. Yeah, I just want to make sure you guys can see this. Okay. So these are tougher problems that will be ready, that will be on this will be tougher than the problems that you guys will see on the test. But if we can handle this, the test should be no big deal. And this is actually a really good warm-up of what the recovery will look like. So if you're going back to the recovery, this should help you out. All right, so let me annotate this and we'll start the problems here. All right, so first couple problems here, we have some questions that are about domain and range and just interpreting the graph. So the range, actually these are kind of backwards of what we normally do. Domain is usually what we do first. We go how far left, how far right. So this goes all the way to the left to -1, and it goes all the way to the right to 2. Now I'm going to use the correct brackets. We do include -1 because it does touch there, and then it's an open dot at 2, so it should be rounded, but I'm not going to be marking you guys off for that. It's something we just really didn't have time to focus and go over on this year with everything crazy. Now range is how low to how high. The lowest point I see on the graph is here at -2. And the highest point I see on the graph is right here at 1. And that's an open dot, so we will use a rounded. Okay, next, what intervals where the graph is positive? So where is the graph above the x-axis? Really, it's only in this range here. This is the only time it is above the x-axis. This is all below, and it gets up to it, but that doesn't count, and it's all below here. So it's only above the x-axis from -1 to 0. So this range on our x-axis. And yes, we'll end with an open dot because that ends with an open dot. -1 to 0. All right, find the x-intercepts. Where does it cross the x-axis? All right, this one here, our x-intercepts. We'd look, and we'd see, okay, it crosses the x-intercept right here at the point -1, 0. And then you probably could argue this, but I wouldn't mark you ever off if you do put the point 1, 0. But that technically doesn't count because that's an open dot and that's not an actual point. It's only -1, 0 is the only point where it crosses the x-axis. And last question here, what is the average rate of change from -1 to +1? Actually, we have these points graphed. -1 here is at 0, 0. +1 is actually, wait, no, we didn't. +1 is marked down here because that's an open dot. So look at the line that this creates going from the starting point at -1 to the ending point at +1. That graph is going down 2 and over 2, which means the average rate of change is -1. All right, so remember you guys can go back, clear these, or go back, watch the videos, redo those. Pause the video at any time if you guys need some help. All right, where is the graph increasing? On y equals 2 plus x minus 3 squared. Okay, so if I were to graph this out, this is a parabola because my parent function notes tell me x squared makes a parabola shape. So it's going to be a U shape, and it's going to be some type of transformation with the U shape because we have some things. Now this 2 is technically on the outside, so it's going to be up 2, and then -3 means it's going to go to the right 3. So something inside the parentheses, say left or right, outside tell you up or down. So really this is a U shape that's to the right 3 over 2. All right, like this. Well, we want to know where the graph is increasing. Well, the graph starts increasing here, which is at 3, and keeps increasing as we move on to the right. Every time we go to the right, this graph is going up. So look back at our x-axis. Where did we mark that at? That's from 3 to infinity. The graph is increasing. Okay. Next, this one's a little tricky here. And in fact, we might want to graph it to double check this here. If we want to identify the transformation of the parent function, absolute value of x, given that g of x equals the negative of 3 plus absolute value of x. Well, if we think about this one here, if we do distribute the 3, this would be negative 3 minus absolute value of x, or in other words, that'd be negative absolute value of x minus 3. Let's go ahead and try to see what this would be graphically. Now, looking over here, we have a minus 3, so this means it's down 3. Then we have a negative, which means it's flipped over the x-axis. So this one's probably low trig, and this is why I probably put it on the review, because you have to think, are we flipping it and then shifting it? Or are we shifting it and then flipping it? So let's double check this on Desmos. I would always highly recommend, when you guys have the opportunity, which will be on the digital part of the test, is to double check everything on Desmos. So they do tell us that the parent function is the absolute value of x. So there's the parent function. Now this one is negative parenthesis 3 plus absolute value of x. Okay, so if we look at this, we can kind of argue this two different ways, and I would always, accept these two answers here, that we could say that this is a reflection over the x-axis and then shifted down to. And this is one of those that we didn't really get into because it does get really kind of tricky here. So two different answers here. We could say it's reflected over the x-axis and then shifted down to. Or no, not down to, down 3. So it goes down 3. The other thing that could happen here, and this is one you'd have to kind of think a little bit outside the box, we could say, or it's shifted up 3. So we're imagining this is shifted up 3. So we got a V shape here. And then this whole thing is reflected over the axis. And then reflected. And all that kind of determines, and you'll get both answers because we could have rewrote the expression reflected over x-axis. So what's going to happen on your test, I'll never reflect it over like the x and then shift it up or down, or same thing, I'll never move it horizontally and then shift it over the y. It's going to be one or the other. Like I'll move it to the left and then shift it over the x, because that doesn't matter what order you do things in. Or I'll move it up and down and then shift it over the y. So don't freak out about anything like that. Remember, I'm putting the tougher ones on here so you guys have the easier questions on your test. All right, so now the graph of the functions, these are going to be closer to what you guys will see on the in-class version. You guys will have a piecewise function. And here we got a very simple one, and we're just going to graph this out. The one on yours, I think, has 3 parts to it. This one just has 2. And so what I want to make sure you guys do is you create your tables and you plot your points. Okay, so if we're going from 0 to 2, we're going to have 0, 1, and 2 in our table, or x, y, and we're going to plug it into the top equation, just x. So if I plug 0 in for x, y would equal 0. If I plug 1 in for x, y would equal 1. Plug 2 in for x, y equals 2. We're going to graph those points out. So 0, 0, 1, 1, 2, 2, 2. But we're going to make sure we use the right kind of dots. Oh yeah, we'll connect the dots here to connect our line. All right, at 0, 0, that should be a closed dot because that's a less than or equal to sign. Less than for 2 would be an open. So this should start with a closed dot and end with an open dot. Now we'll make another table here for our second part of the graph, x, y, and we're going to go from 2 to 4. So 2, 3, 4, and we're going to plug these numbers into here. So 2 minus 2 is 0, 3 minus 2 is 1, 4 minus 2 is 4, and we'll plot those points out. So 2 is at 0, 3 is at 1. Oh wait, I can't do math. 4 minus 2 is 2. Yeah. All right, so if we want to look at here, our graph is going to start out open because that's a less than, and end closed. So we'll start out with an open dot, draw our line, and close it to connect over here. So there's our equation. There's your graph. So you'll have a piecewise function that you'll have to plot those points out and graph them. So the one thing I'll be checking is like, all right, is each one of these piecewise functions at the right points? And then do you have the right dots? So that one should be pretty easy. All right, last, systems of equations. So you guys will have two of these to do. One will be online, and then one of them will be on paper. The online ones you guys can always double check by typing them into Desmos, at least for the 2 variable. The other one you'll have to go through and do the math. The ones that are online I didn't make as worth as many points as the ones that will be on paper, because the ones on paper I can check for more things. So I didn't want one small mistake to hurt your points out as badly. So let's go through the first one here. We're going to solve by using elimination, because that's the method that will work for both of these problems. So we got x's on x's, y's on y's. What we need to do is multiply one of these to get rid of the variable. I'm going to multiply the top row by -4 here. So I can get -4x minus 8y equals -16. The bottom stays 4x plus 5y equals 7. Now that we have opposite x's, we can add them together, and those that get eliminated. -8y plus 5y is a -3y, and -16 plus 7 is a -9. We can divide here. Y would be 3. What we then need to do is take that value and plug it back in to find any x. So I'll plug it back into the first problem. X plus 2y, or 2 times 3, equals 4. So that means x plus 6 would equal 4. And subtract the 6, x would be -2. So that means our answer, x is -2, y is 3. So these two lines would cross at the point -2, 3. Remember, rewatch these videos, try them on your own, go back, pause it, make sure you guys get the right answer. Do the steps that you need to take to make sure you understand this. All right, a 3 variable system of equation. All right, let's get this started here. I'm going to label them A, B, and C. And this one doesn't look like it's going to come out nice. All right, so I'm going to do, I like just this plain old, I actually like this -z here. So I'm going to do A and C together first. Yeah, and so that's going to be a 3x minus 3y plus 6z equals 6, and x plus 2y minus z equals 5. Okay, so I'm going to multiply this bottom row by 6. Remember, there's so many different ways you can do the same problem, and you'll get the same answer in the end. So the top row doesn't change. The bottom row, when I multiply this by 6, I get 6x, 12y minus 6z equals 30. We'll add them up. And let's see, I would have 9 x's then, and I would also have 9 y's, and the z's go away, and this would be 36. Okay, next what we need to do is do another group here, but we can't do A and C. We either need to do A and B or B and C to get rid of Z. I think B and C is going to be a little bit easier. We can do A and B, but I wouldn't recommend it. So B and C, we get 5x minus 8y plus 13z equals 7, and x plus 2y minus z equals 5. So to cancel out the z's, I got to times this bottom by 13. Hopefully we know our 13's times tables. So we got 5x minus 8y plus 13z equals 7. And the bottom timesing it by 13. It'd be 13x plus 26y plus 13z equals, okay, 5 times 13 would be 50 plus 15 be 65. All right, add them together. Let's see, we'd get 18x, and then, we get 18y. Oh no. Did I really going to give you guys a problem that doesn't work out right? Yeah. Would that be 18? Yeah, it would be 18. And then equals, add them together, 72. Now, the reason why I said, oh no, is because of this. And this randomly, when I make up numbers, this happens. I guess I should double check this. So when you guys are in class the day before, make sure you guys ask, and we'll go over multiple one of these. But what we would do next would be to stack our answers together. 9x, 9y equals 36. 18x, 18y equals 72. Oh, actually, this is kind of crazier. So if I multiply this by 2, I would get 18x plus 18y equals 72. 18x plus 18y equals 72 as well. Actually multiply by, but we get the exact same answer. So this isn't no solution. This is actually all solutions, because we have the same thing. So typically what would happen next is we simplify this down and be like a problem before. And that's what will happen. I've already double checked your answer keys on your guys' test. They will come out nice. So just, I mean, wow, it's kind of crazy that I just made up some numbers here and they worked out to be an identical solution here. All right, well, that narrows it down a bit. So what we need to do now is just make sure you guys ask your questions, you go through it. So the test is gonna be a little bit different since this year's a little bit different. You'll take your online part on the day you guys are not here, so either Thursday or Friday, and then you guys will take the paper test, which will be like the last 3 problems of this optional review on the day that you are here. So feel free to kind of go back, look at the review, you know, the day before. That test you guys do get 2 attempts on. So you guys can go ahead. Now you won't see your answers because I definitely don't want anybody to, you know, just do it once and then tell your friends, okay, hey, this is what I typed in and I got a, you know, 95 on it. Just type the same answers in. And there's also different questions. So there is a question bank. So you can kind of just take the test twice. Hope you did good on it and get a better score. All right, guys, so that ends this review. Hopefully you guys are ready and prepared for the test. I think you guys will do all right. Thanks for watching.